The electrical contractor's behavior highlights a critical issue, whether they are qualified. The act of not reading specifications is a red flag. If the electrical contractor doesn't read specifications, lies about it, and avoids responsibility when the authority having jurisdiction arrives, it is a sign of a problematic situation. A suitable approach in this scenario is to allow them to proceed as they wish. Then, when the authority having jurisdiction requires changes and the electrical contractor is absent, the consequences of ignoring expert advice become apparent. It is a concerning commentary on the electrical industry that many electrical contractors do not read or possess specifications. This situation explains why some consultants are successful. They provide guidance to contractors or electrical contractors and disengage if the authority having jurisdiction rejects the work. This type of attitude reflects a desire to minimize effort while maximizing compensation, unwillingness to invest in training or education, and avoidance of accountability. Consequently, these electrical contractors risk becoming increasingly irrelevant in the construction sector. To ensure qualified electrical contractors, one must prioritize certain aspects. Firstly, verify their understanding of the National Electrical Code and relevant local amendments. Secondly, assess their experience with similar projects, focusing on their ability to interpret and implement project specifications. Thirdly, check their references and reputation within the industry, contacting previous clients or colleagues for feedback. Fourthly, ensure they possess the necessary licenses and insurance, validating their legitimacy and protection against potential liabilities. Fifthly, evaluate their commitment to continuing education and professional development, indicating their dedication to staying updated with industry advancements. Sixthly, scrutinize their bidding process, examining the thoroughness and accuracy of their cost estimations. Seventhly, clearly define roles and responsibilities, establishing a transparent communication channel and accountability framework. Eighthly, conduct regular site inspections, monitoring compliance with safety standards and project specifications. Ninthly, maintain open communication, fostering a collaborative relationship and addressing concerns promptly. Tenthly, document all agreements and changes, creating a comprehensive record of project decisions and modifications. This comprehensive process will help ensure the selection of a qualified electrical contractor who prioritizes safety, quality, and compliance. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and updated every 3 years by the National Fire Protection Association, or NFPA. The NEC aims to ensure electrical safety and prevent fire hazards by providing detailed requirements for wiring, grounding, overcurrent protection, and other electrical components and systems. It is widely adopted by state and local jurisdictions, serving as the foundation for electrical codes and regulations nationwide. Compliance with the NEC is essential for electrical contractors, engineers, and inspectors to ensure safe and reliable electrical installations. Some key areas covered by the NEC include: firstly, general requirements, which outline fundamental principles and definitions applicable to all electrical installations. Secondly, wiring and protection, which addresses the selection, installation, and protection of conductors, cables, and raceways. Thirdly, wiring methods and materials, which specifies approved wiring methods and materials for different applications and environments. Fourthly, equipment for general use, which covers requirements for electrical equipment such as receptacles, switches, and lighting fixtures. Fifthly, special occupancies, which addresses unique electrical requirements for specific locations such as hazardous locations, healthcare facilities, and swimming pools. Sixthly, special equipment, which covers requirements for specialized equipment such as elevators, walters, and electric signs. Seventhly, communications systems, which addresses wiring and protection requirements for communications systems such as telephone, data, and cable television. Eighthly, tables and examples, which provides detailed tables and examples to assist in applying the code requirements correctly. Electrical safety is of paramount importance in all electrical installations and work practices. It involves taking precautions to protect individuals from electrical shock, burns, and other hazards associated with electricity. Some key principles of electrical safety include, firstly, de-energizing circuits before working on them, ensuring that power is disconnected and properly locked out or tagged out to prevent accidental energization. Secondly, using personal protective equipment, or PPE, such as rubber gloves, insulated tools, and safety glasses to minimize the risk of electrical contact and injury. Thirdly, maintaining proper grounding, providing a low resistance path for fault currents to flow, reducing the risk of electric shock. Fourthly, avoiding contact with energized parts, keeping a safe distance from exposed conductors and electrical equipment. Fifthly, following lockout/tagout procedures, ensuring that equipment is properly de-energized and tagged out before maintenance or repair work. Sixthly, using ground fault circuit interrupters, or GFCIs, in wet or damp locations to protect against electrical shock hazards. Seventhly, inspecting electrical equipment regularly, checking for damaged cords, loose connections, and other potential hazards. Eighthly, providing electrical safety training, educating workers about electrical hazards and safe work practices. Ninthly, adhering to electrical codes and standards, complying with the National Electrical Code and other applicable regulations. Tenthly, reporting electrical hazards, promptly reporting any unsafe conditions or potential electrical hazards to the appropriate authorities. Training and education play a vital role in the electrical industry, ensuring that workers have the knowledge and skills necessary to perform their job safely and effectively. Some key areas of training and education include, firstly, electrical theory, understanding the fundamentals of electricity, including voltage, current, resistance, and power. Secondly, electrical codes and standards, learning about the National Electrical Code and other applicable regulations. Thirdly, safety practices, mastering safe work practices and procedures, including lockout/tagout, PPE, and grounding. Fourthly, troubleshooting and maintenance, developing skills in diagnosing and repairing electrical problems. Fifthly, installation techniques, learning proper installation methods for various electrical systems and equipment. Sixthly, blueprint reading, interpreting electrical drawings and diagrams. Seventhly, instrumentation and testing, using testing equipment to verify the safety and performance of electrical systems. Eighthly, continuing education, staying updated with the latest advancements in electrical technology and codes. Ninthly, apprenticeship programs, participating in structured apprenticeship programs to gain hands-on experience and mentorship. Tenthly, certifications and licenses, obtaining certifications and licenses to demonstrate competency and professionalism. The authority having jurisdiction, or ARJ, is a term used in the National Electrical Code and other codes and standards to refer to the organization, office, or individual responsible for enforcing the requirements of a code or standard, or for approving equipment, materials, and installation, or a procedure. The AHJ may be a local building official, fire marshal, electrical inspector, or other regulatory authority. The AHJ plays a crucial role in ensuring compliance with codes and standards and in safeguarding public safety. Some key responsibilities of the AHJ include, firstly, reviewing and approving electrical plans and specifications, ensuring that they meet code requirements. Secondly, conducting inspections of electrical installations, verifying compliance with codes and standards. Thirdly, issuing permits for electrical work, authorizing qualified individuals to perform electrical installations. Fourthly, enforcing codes and standards, taking action against violations and ensuring compliance. Fifthly, interpreting codes and standards, providing clarification and guidance on code requirements. Sixthly, investigating electrical incidents, determining the causes of electrical failures and accidents. Seventhly, promoting electrical safety, educating the public and industry about electrical hazards and safe practices. Eighthly, adopting and amending codes, adapting national codes to meet local needs and conditions. Ninthly, training and certifying electrical inspectors, ensuring that inspectors have the necessary knowledge and skills. Tenthly, collaborating with other agencies, coordinating with fire departments, building departments, and other regulatory agencies. Compliance and standards are essential aspects of the electrical industry, ensuring that electrical installations and equipment meet minimum safety and performance requirements. Some key areas of compliance and standards include, firstly, National Electrical Code, adhering to the requirements of the National Electrical Code for electrical installations. Secondly, underwriters' laboratories, or all, listing using UL-listed products that have been tested and certified for safety. Thirdly, American National Standards Institute, or ANSI, standards, complying with ANSI standards for electrical equipment and components. Fourthly, National Electrical Manufacturers Association, or NEMA, standards, following NEMA standards for electrical enclosures and other products. Fifthly, International Electrotechnical Commission, or IEC, standards, considering IEC standards for global electrical installations and equipment. Sixthly, Occupational Safety and Health Administration, or OSHA, regulations, complying with OSHA regulations for workplace electrical safety. Seventhly, state and local codes, adhering to state and local electrical codes and regulations. Eighthly, industry best practices, following industry-recognized best practices for electrical installations and maintenance. Ninthly, documentation and record keeping, maintaining accurate records of electrical installations, inspections, and maintenance. Tenthly, continuous improvement, striving for continuous improvement in electrical safety and performance. In summary, the electrical contractor's approach underscores the significance of qualification. The lack of adherence to specifications acts as a warning signal. Neglecting to read specifications, dishonesty, and avoiding accountability when dealing with the authority having jurisdiction are all telltale signs of potential issues. A well-considered strategy involves allowing them to proceed, and then when the authority having jurisdiction mandates alterations and the electrical contractor cannot be found, the repercussions of disregarding professional counsel become self-evident. It casts a shadow on the electrical sector that numerous electrical contractors fail to read or maintain specifications. This circumstance clarifies the success of some consultants who offer direction to contractors or electrical contractors and withdraw if the authority having jurisdiction disapproves of the work. This mindset mirrors a tendency to reduce effort while maximizing compensation, a reluctance to invest in training or education, and a disinclination to accept responsibility. Consequently, these electrical contractors run the risk of becoming progressively inconsequential within the construction field. To guarantee the selection of proficient electrical contractors, one must prioritize various elements. To begin, validate their comprehension of the National Electrical Code and pertinent local revisions. Subsequently, evaluate their experience with analogous projects, concentrating on their aptitude to interpret and implement project specifications. Afterward, examine their references and standing within the sector, reaching out to past customers or associates for input. Also, ensure they possess the required licenses and insurance confirming their legitimacy and safeguarding against conceivable liabilities. Further, assess their dedication to ongoing education and professional growth, signifying their commitment to remaining informed about sector progress. Additionally, scrutinize their bidding procedure, assessing the meticulousness and precision of their cost assessments. Moreover, explicitly delineate roles and duties, establishing a transparent communication pathway and accountability structure. In addition, conduct routine site evaluations, overseeing conformity to safety protocols and project specifications. Furthermore, sustain open lines of communication, promoting a collaborative alliance and promptly addressing concerns. Above all, document all agreements and alterations, generating a thorough record of project choices and adjustments. This all-encompassing procedure will aid in securing the engagement of a skilled electrical contractor who places a premium on safety, quality, and adherence. The National Electrical Code, abbreviated as NEC, stands as an exhaustive compilation of standards and directives for electrical installations across the United States. It undergoes development and revision every 3 years through the National Fire Protection Association, or NFPA. The NEC is designed to guarantee electrical safety and mitigate fire risks by offering comprehensive stipulations for wiring, grounding, overcurrent defense, along with other electrical components and systems. It enjoys widespread adoption by state and municipal jurisdictions, serving as the cornerstone for electrical codes and protocols countrywide. Adherence to the NEC is vital for electrical contractors, engineers, and inspectors alike, ensuring the creation of secure and dependable electrical installations. Prominent domains encompassed by the NEC encompass: firstly, universal mandates, which delineate fundamental tenets and definitions applicable to all electrical installations. Secondly, wiring and safeguarding, addressing the selection, setup, and shielding of conductors, cables, and raceways. Thirdly, wiring methodologies and materials, stipulating sanctioned wiring techniques and substances for diverse applications and settings. Fourthly, equipment designated for universal usage, encompassing prerequisites for electrical apparatus like receptacles, switches, and illumination fixtures. Fifthly, specialized occupancies, tackling distinctive electrical requisites for precise locales such as hazardous zones, healthcare amenities, and swimming pools. Sixthly, specialized equipment, addressing stipulations for specialized apparatus like elevators, welders, and electric signage. Seventhly, communication infrastructures, tending to wiring and safeguarding protocols for communication infrastructures like telephone, data, and cable television. Eighthly, charts and illustrations, furnishing meticulous charts and illustrations to aid in the accurate implementation of code stipulations. Electrical safety retains utmost significance in all electrical installations and operational methodologies. It entails adopting safeguards to shield individuals from electrical shock, burns, and other perils linked to electricity. Some cardinal principles of electrical safety involve: firstly, de-energizing circuits prior to undertaking any work, guaranteeing that power is disconnected and appropriately locked out or able to avert unintentional activation. Secondly, employing personal protective equipment, abbreviated as PPE, encompassing rubber gloves, insulated instruments, and safety eyewear to curtail the risk of electrical contact and injury. Thirdly, upholding proper grounding, provisioning a low-resistance pathway for fault currents to traverse, diminishing the potential for electric shock. Fourthly, steering clear of contact with energized components, sustaining a secure separation from exposed conductors and electrical machinery. Fifthly, abiding by lockout/tagout protocols, affirming that machinery is suitably de-energized and labeled before maintenance or repair endeavors. Sixthly, utilizing ground fault circuit interrupters, referred to as GFCIs, in humid or damp locales to safeguard against electrical shock threats. Seventhly, routinely inspecting electrical machinery, scrutinizing for compromised cords, unsecure connections, and other latent hazards. Eighthly, delivering electrical safety instruction, enlightening personnel about electrical perils and secure operational procedures. Ninthly, adhering to electrical codes and benchmarks, aligning with the National Electrical Code and other pertinent regulations. Tenthly, reporting electrical threats, promptly documenting any precarious circumstances or prospective electrical dangers to the relevant authorities. Training and education assume a crucial function within the electrical sector, guaranteeing that personnel possess the requisite knowledge and capabilities to execute their responsibilities securely and proficiently. Pivotal domains of training and education comprise: firstly, electrical theory, grasping the fundamentals of electricity, encompassing voltage, current, resistance, and power. Secondly, electrical codes and criteria, acquainting oneself with the National Electrical Code and other applicable stipulations. Thirdly, safety protocols, mastering secure operational methodologies and procedures, encompassing lockout/tagout, PPE, and grounding. Fourthly, troubleshooting and upkeep, cultivating proficiencies in diagnosing and rectifying electrical complications. Fifthly, installation methods, acquiring proper setup techniques for diverse electrical systems and apparatus. Sixthly, blueprint interpretation, deciphering electrical sketches and schematics. Seventhly, instrumentation and scrutiny, employing testing apparatus to validate the safety and performance of electrical systems. Eighthly, continuous learning, remaining current with the most recent advancements in electrical technology and codes. Ninthly, apprenticeship initiatives, engaging in structured apprenticeship schemes to garner practical involvement and mentorship. Tenthly, certifications and licenses, securing certifications and licenses to showcase competence and professionalism. The authority having jurisdiction, known as AHA, is a term found in the National Electrical Code and other codes and standards, denoting the entity, office, or individual entrusted with enforcing code mandates, approving equipment, materials, installations, or procedures. The AHA could be a local construction official, fire marshal, electrical inspector, or regulatory body. The AHA is vital in ensuring code compliance and safeguarding public safety. Key AHA roles include: firstly, reviewing and approving electrical blueprints, ensuring compliance with code needs. Secondly, inspecting electrical setups to verify code adherence. Thirdly, issuing permits for electrical tasks, allowing qualified individuals to conduct installations. Fourthly, enforcing codes and standards to address violations. Fifthly, interpreting codes to guide code understanding. Sixthly, investigating electrical events to determine causes of failures. Seventhly, promoting electrical safety through public and industry education. Eighthly, adopting and modifying codes to adapt national standards to local conditions. Ninthly, training and certifying electrical inspectors to ensure necessary skills. Tenthly, collaborating with agencies like fire and building department. Compliance and standards are critical in the electrical sector for safety and performance. Key areas include: firstly, National Electrical Code or NEC compliance for electrical setups. Secondly, Underwriters Laboratories or UL listing for tested and certified products. Thirdly, American National Standards Institute or ANSI standards for equipment compliance. Fourthly, National Electrical Manufacturers Association or NEMA standards for enclosures. Fifthly, International Electrotechnical Commission or IEC standards for global considerations. Sixthly, Occupational Safety and Health Administration or OSHA regulations for workplace safety. Seventhly, adherence to state and local codes and regulations. Eighthly, industry best practices for installations and maintenance. Ninthly, meticulous documentation of electrical installations and maintenance. Tenthly, striving for continuous improvement in electrical safety.